sometimes in a question you are given the graph and you will be asked to determine the equation of a certain parabola. Okay, now I'm going to show you how to do that. So before I start with anything, you have to know I'm going to introduce something. So okay, in order to determine the exact equation of a parabola, you have to know minimum 3 individual points. 3 points. Okay. Or you have to know the turning point and one other point. Okay. This is the minimum requirement to determine the exact equation of a parabola. This is the minimum requirement. If you don't have enough information, you can't determine the exact equation of a parabola. Okay. Now, the parabola, as I told you before, has a general formula of y equals to ax squared plus bx plus c, where a, b, c are constant or coefficients. So, or a parabola can be in this form: y equals to a is a constant or coefficient of x squared, x plus a certain number, and x plus another different certain number. Okay, or your parabola can have an equation of a x plus a certain number square and plus other certain number there. Okay, this is basically how do we this is basically the 3 forms of parabola. Okay, 3 forms of parabola. Okay, now let's do some examples. I show you how do we use those equations to solve a problem. Let's look at the example questions here. Question A. In question A, we have a parabola, and we have 3 individual points. Okay, we have 2x in the graph. They show you the 2x-axis and x-intercept and the y-intercept, which is -12. So in question A, we have 3 individual points, coordinate 0, -12, and the coordinate -3, 0, and the coordinate 4, 0. Okay. There are 2 ways of doing it. Let's do it. Okay. There are 2 different ways of doing it. Let's do it by the simple way. Okay, I prefer. So, because in this parabola, in the graph already showed us the x-intercept, and we can use this formula here. Okay, because we know x-intercepts are taught, it's simple to use this formula. Okay, so we have y equals to a x plus a number and x plus another number bracket. Okay, so now we look at the graph. When x, okay, when y is 0 in this graph, okay, sorry, oh, something wrong, yeah, sorry about that, it's not, okay, yes, just when y equals to 0, because we know the x-intercept, x is equals to minus 3 and positive 4. Okay, let's look at the formula. We have to substitute it into this equation. So your y will be a bracket x plus 4 plus 3, sorry, and x minus 4. Only in this equation, so this is our number there. You have to, the idea is you have to actually put this number here, and times minus 1, and move this number up, and times minus 1, times, this is times minus 1. Okay, because only this way, when y equals to 0, we can have a minus 3. When y equals to 0, we can have a minus 3, and x can be 4 as a solution. Okay, so simple as that, we have our solution, but we still have to find the value of a. We find it by substitute the y-intercept in it. So when x equals to 0, the graph shows us y is going to be minus 12. Okay, now we substitute this into this equation. Okay, then we have minus 12 equals to a 0 plus 3 and 0 minus 4, which is minus 12 equals to a times minus 12, and a is 1. Okay, when a is 1, so our solution is x plus 3 and x minus 4. Okay, it's very simple to do. The first thing we have to do is to determine which formula do we use here. If we are giving the x-intercept, we can just use this formula. Okay, if we are giving the turning point, we have to use this formula. Okay, if we are given by the turning point, then we have to use this formula here. I show you how we do it later. Okay, this is for if we know the x-intercept, we use this formula. If we know any 3 individual points, we use this formula. Okay, I show you how do we use this formula Okay, now let's do the same equation A, using the formula here. Okay, so assume we have y equals to ax squared plus bx plus c, and we have our 3 points there. Let's substitute all the points into the equation. First, we substitute the y-intercept. We substitute this point in. So when x is 0, y equals to 12. So we just substitute the number in. Y is minus 12. X is 0. So a should times 0 square and plus b times 0 plus c. Your c will be minus 12. Okay. Now we found one constant of the parabola, and now we have to find b and c. Let's substitute the other point coordinates. So when x is minus 3, y equal to 0. So we have 0 a times bracket minus 3 square plus b times minus 3 minus 12, because c is 12, we found it out there. And now we have 12 equals to 9a plus 3b. Okay. Then we substitute the point 4 and 0 again into the equation here. So when y equals to 0, when x is x is 4. So you have, well, we have 16x, 16a, because 4 times 4 is 16, plus 4b minus 12. Okay. And 12 will be 16a plus 4b. Now we have two simultaneous equations. This is our equation 1, this is equation 2. Okay. I will do another tutorial on how do we solve simultaneous equations. You should cover this in year 9. In year 10. If you don't know how to do it, well, later, maybe sometimes next week, I try to do another tutorial. Okay. The idea to solve it, I just make it simple. The idea to solve it is, okay, let's look. We have 16a here and 9a in this equation. So we have to equation 1 equation 1 have to be divided by let's say we have 3b there and 4b there. So equation 1 have to be divided by 3 and times 4 minus equation 2. Okay, so we have equation 1 divided by 3 times 4, so we have 16 minus 12 equals to 12 minus 16a. Okay, and your result is a equals to 1. Let's say divided by 3 times 4, and well, a should be equals to a should be equals to 1